Let's take a look at solution sets of inequalities. Remember, equations have just one solution, but solutions to inequalities are not going to be single numbers. Instead, inequalities will have more than one value for a solution. For example, this inequality here on this number line, this would be read as the solution set is all numbers greater than or equal to -5. Because think, there's not just one answer to what numbers are greater than or equal to -5. There's an infinite amount of numbers. You could have 0, you could have -2, you could have 7, just to name a few. It's not just one solution. So we have a solution set instead of just one number. We're not just going to have one dot on the number line. We're going to have an infinite amount of dots, which is looking almost like a shaded region. Now, we can test and name specific solutions to a given inequality. For example, we have r is greater than 10. So we have a solution set of 5, 10, 15, and 20, and we can test which of the following would be solutions. So we need to take the inequality, so we have r is greater than 10, and we would need to substitute each of the solutions into the inequality to see which ones would be true. So if r is greater than 10, first we're testing 5. So if we input or substitute the value of 5 for r, that would give us 5 is greater than 10. But that's not true. So that means 5 is not a solution. Now let's test 10. Then r is greater than 10 if we're substituting 10 for r. 10 is greater than 10 is not true either. So 10 is not a solution either. Now let's test 15. R is greater than 10. If we substitute 15 for r, that gives us 15 is greater than 10, and that's true. So 15 would be a solution. Now finally, let's test 20. R is greater than 10. If we substitute 20 for r, that gives us 20 is greater than 10, which is true as well. So it was a true statement when we substituted in the values of 15 and 20, but not for 5 and 10. So 15 and 20, that solution set would be solutions to the inequality, where 5 and 10 would not. Let's look at one more example. Here we have 30 is greater than or equal to 5 times d, and we're checking the solutions of 4, 5, 6, 7, and 8. And again, that's for your variable of d. So we need to substitute in each of these 5 numbers for d and see which ones make true statements versus false statements. As you can see below, if we're substituting in 4, 5, or 6, it will produce true statements. You get 30 is greater than or equal to 5 times 4, which is 20. 30 is greater than or equal to 5 times 5, which is 25. And 30 is greater than or equal to 5 times 6, which is 30. So those, again, are all true statements. This is versus if we substitute in 7 for the variable d and 8 for the variable d. Then you end up with 30 is greater than or equal to 35, which is not true. And you end up with 30 is greater than or equal to 40, which is not true. So the only numbers that can be a part of the solution set are 4, 5, and 6. We have to exclude the 7 and the 8 because they produced false statements. So the following numbers of 4, 5, and 6 are the only solutions in this case out of that solution set.